What was that approach that Bitcoin took? Bitcoin took a small blocks approach. Welcome to Ready Foresights. Let's answer the question, the difference between layer 1 networks, layer 2 networks, this kind of scaling question. Why do we need scaling? Why is data so important and integral to understand the problems that we can occur with scaling? So for example, let's first look at Bitcoin. Back in 2017, 2016, all the way back to around 2014. For reference, you can look at the book Blockchain Wars. This is a book that discusses the events that took place during that time period of this conflict about how to scale Bitcoin. They said, okay, we should have large blocks and we should have small blocks. Do we have less groups of people validating, more groups of people validating? Who has the consensus at the end of the day? Is it the miners? Is it the nodes? Is it the developers? Do the developers just get to change the code anytime they want? This was a real test of blockchains and their ability to actually harden themselves, to not just be able to change. Where you couldn't have a party that's, okay, let's say these are the people who are able to approve the code for the repository. Can those people just make any change in the code and then everyone else in the network just follows? These theories need to be tested out over time, whether or not this was possible, whether or not that all the nodes and all the miners would just go along with the developers in whatever way they changed the code. And what we ended up finding out is that Bitcoin forked itself many times. People took the code, some people made completely illegitimate projects where they weren't trying to do anything, and some people genuinely had a different approach. The approach at the end of the day that we can see won out in the market is Bitcoin. The other ones have fallen way down the list. What was that approach that Bitcoin took? Bitcoin took a small blocks approach. This was focusing on data being small so that more nodes could run on the network. This created a network where many people were able to check that accounting that was happening on the network. Whether they were mining or not mining, they could actually check and have their own copy of the ledger, that if somebody were to try to corrupt the ledger later, they could literally take their copy, go over here, restart the network with the other people who also agreed that they didn't like the approach that the developers were running away by themselves, or that all the miners revolted and they went a different way. This allowed people to protect themselves because they had this copy. In the end of the day, this was the initial premise of a trustless nature of blockchains, is that people could actually have a copy of the blockchain, and by having a copy of the blockchain, they didn't need to trust anyone because their blockchain node was doing their validation, that it was accurate, and there was no single entity just doing this validation. Traditionally before that, we couldn't separate the validation, we could only have a business do the validation. Now, we look forward. So what has Bitcoin done since then? Bitcoin has built something called Lightning Network. Lightning Network is state channels that allow individuals to pass money back and forth by basically making several state channels. So saying party A and party B, you can pass money between each other. But then party C is connected to party B. So let's give them names. Let's say Sally, Bob, and Tom, okay? These three are all connected. Bob and Tom can only transfer money to each other. Let's say that they both put in 1 Bitcoin. They can only transfer back and forth. But Sally here on the other side, if she wanted to get money all the way through, past Bob to Tom, she could actually do so by sending across her state channel. The balance gets balanced between these two, and then other two rebalance their balance based on the previous balance. And this is done in a way where nobody actually knows who later down the chain got the funds, because the funds are wrapped in layer by layer, similar to onion routing. They're opened up only with the instructions of where to go next, not who the final recipient is. This is what Lightning Network does. One of the reasons that this is important is, say that me and the coffee shop, I want to buy a donut every minute for the whole day. Well, every minute I'm going to the coffee shop, I buy a donut, and I buy another donut, and I buy another donut. In a traditional blockchain approach, all of that data needs to get transferred to the thousands of nodes around the world who are all recording that I went and bought one donut, and I went and bought another donut, and I went and bought another donut. The consensus idea behind this state channel mechanism is, as long as the finality of our channel between us two parties is correct and validated by the network, as long as we can have our records that sign off all the transactions along the way based on a specific system, it really doesn't matter that much recording all of the details along the way. Because in the end, by using the same mechanism to use the main network to check the transactions, we can actually show that everything that took place up to that point must be accurate, because here's the final result that we both signed off on. And there's other mechanisms built into that, so if one person just goes off the internet and doesn't come back, there's a mechanism to handle that. There's a mechanism to handle if the person lies, in which case the person who catches that person lying would actually receive funds. That person who was doing the lying would lose their funds, so they're incentivized to not lie. If you have any questions about blockchain, please put them below in the comments, like and subscribe, and we'll see you with the next video.